was also asked, if possible, to give you some ideas of what perhaps South Africa can do to supply this equipment with the necessary energy, or any kind of refrigeration equipment for that matter. In order to cover this one, I started like this. I went to look at some of the African press that I could find, and here are some. Number one, you all know that the parliament approved a carbon tax. Interesting. But they also gave a grace period until almost 2022 for most of them. So you know what is coming. So there is a carbon tax, which is a good thing to do. And I will commend South Africa, because in Germany we just cannot make up our mind if that is a good idea or a bad idea. Personally, I think it is absolutely necessary. Because you have load shedding and because you have fuel shortages, people started a run on solar panels and also on storage batteries, because you need to operate. You cannot just, because there's load shedding, you cannot stop refrigeration. Of course, it's necessary. So there is a run to produce energy, and actually not far from here where we stay in Vrede and Lust, they have a large solar array to produce the necessary electricity for their own operations and perhaps even to feed into the grid. Now, how can South Africa solve it is also from the newspapers. Here, this guy, Steve Hedden, he's a researcher in Pretoria. He already made this statement in 2015. He thinks rethinking the electricity distribution is part, or at least a large part, of the solution. I think so also, and I go in that direction with my next slides. How can you possibly rethink or redo your electricity distribution system? I'm aware Eskom is not here. The people in Eskom have other ideas. I can assure you, in Germany, our monopolies, our electricity monopolies, had also different ideas when this whole thing started. It will take a little while, but eventually these are human beings, these are people, they come around, it's good business, and they will eventually go that way. So how could it possibly be? You want to leapfrog, you don't want to do all the interim steps. So some of the elements that are of importance, yes, for quite a while we have to look for energy efficiency. It's not a good idea to waste energy and then to generate energy in order to supply the waste. You have to go for renewable energy, and there are many sources usually, and in this video that we saw earlier, it was mentioned wind and solar and I forgot the third one. Biogas perhaps is one, but you also have wave power. You have a huge coastline where you have very strong currents. Australia is leading the way there. You can look down there, and so on. And how do you distribute this power? There are two keywords that I would like to leave with you tonight: virtual power plants and microgrids. To some extent, they can be interchanged, and I will show you examples. And obviously, it is a good idea to do what we know as trigeneration, not to generate electricity and then have an air conditioning equipment and have a cooling tower and let that heat go elsewhere. That is not good business. So trigeneration means you are generating with one piece of equipment electricity, heat and cold, and perhaps even in some workshop I've seen maybe even compressed air and other forms of energy. And that is something that here in South Africa is already well understood. If you generate solar energy, you have the peak at noontime when the sun is highest, and you have very little in the morning and very little in the afternoon and nothing at night. So what do you do with your oversupply at noon? There's too much, nobody needs it, everybody's out for lunch. You have to store it. And there are various things. You can store energy in form of hot water, or you can store energy in form of ice, and I'm going to give you a nice example later. You can use the energy to split water to make hydrogen out of it, hydrogen gas, and store that as an energy supply, and then use it again with a fuel cell. Obviously, you can use batteries, but batteries is only one small segment. Don't think you can use batteries for everything, and Some people go very wrong, like the Australians have now the biggest battery of the world, which I think is very expensive and doesn't last very long. And there is something of quite some interest. Maybe you have a friend from Eskom, or maybe you talk about it, or maybe somebody from Eskom will suddenly listen. Pump storage is an interesting thing which we missed in Germany. So what is pump storage? If you have surplus energy, you can, for example, pump water from the surface to a reservoir up in a hill or in a mountain. And then when you need that energy, which you have pumped up and saved up there, you let it fall down through a turbine, and then it is down again, waiting to be pumped up at times when you have an excess of energy. So that's pump storage. Now, in Germany, all sites that lend themselves to it have already been taken. So the Germans were thinking, what can we do? And somebody had a brilliant idea. They said, oh, we are not digging coal anymore out of the earth, but we still have these mines. And instead of pumping water up, why don't we let it fall down? And then when we have excessive energy, we can pump it back up and then let it fall down. It's essentially the same, except you let it fall down into a hole, and the hole is there. So it's a nice thing, except the problem was we had most of our mines we had already capped, filled with water or filled with some sand and sediment, and then capped them so that there could be no accident or no incident. So in Germany, this is probably not possible. We went with this idea to China. The Chinese have something which they call the Ruhrgebiet of China, so like the German Ruhrgebiet, where we used to have coal and heavy industry. And they have lots of mines which they now do not want anymore to operate, because also the Chinese have decided no more additional coal-fired plants. What they still have, they will still use, but no more new ones. So they have these ones, and they were delighted about this idea, and I'm sure they are about to think how they can implement it. Africa might have, I don't know, you have mines, maybe not coal, maybe that's just on the surface, but maybe you have diamond, gold, or whatever exhausted mines where Eskom could, or any private entity for that matter, could actually make money storing energy. This is just on the side, and forgive me for expanding on it. I thought it's a brilliant idea. Now, my friends from Aldi again, Aldi Nord in this case, are looking for that implementation of what I'm just suggesting. They look for renewable energy and energy storage. These guys in the north, they are not yet there. They are evaluating as we speak. This is a relatively new slide. They are evaluating different storage technologies that they might want to use, but yes, they are going in the right direction. They are already producing a lot of energy on their roofs here. This is why I have this picture, because the roof has lots of solar panels on it, and most of it they use themselves. Now, when they started doing this one, they did something which every enterprise has to do. They evaluated first where is our problem actually? Where do we have most energy consumption? This picture here shows it in CO2 equivalents. You could also express this in kilowatt hours or megawatt hours, and so this is just one way of calculating it. And yes, they assessed it, and they came out with these numbers here for their distribution and storage units, for their shops, for their transport, and so on. Even here a little forklift. So the next slide, and I will quickly go through that one, shows what is relevant for us. 17% is due to refrigerant losses. That is not refrigeration, that we have here, cooling. That is 59%. Some of it is due to cooling, but they have an issue with HFC leaking out of their systems. And again, that incident where I was talking to the Aldi manager of the refrigeration systems, we were listening to a professor, and he said, you know, the systems lose about 5 to 6% annually of refrigerant. And we were talking, and he said, you know, this is not true what he says, because he, in his statistics, does not put the so-called catastrophic leaks. If somebody rolls over a refrigeration pipe and it's broken, and all the refrigerant goes out, and that is mostly not counted in the statistics. So that's much more than those 3 to 5% that they were saying. Here is the ice storage with the company Viessmann. Aldi Nord did this concept, the slides which I have shown you, and in this case they have come up with actually not a new technology, but for them they have put this concept into a nice thing. This is a tank underground, is sitting in the earth, and it is being ice water sludge, an ice water sludge. And perhaps we know from our classes, physics classes, when there's a phase change between ice and water, a lot of energy is being transported due to this phase change. And that's what they are exploiting here. And so when they have too much solar energy, for example, from their solar panels, they make ice, and then they can use it at other times by extracting the energy from the ice again. Now, Mr. Ackermann, Cold Link, we had in 2011 a project going on here with regards to transport refrigeration, because transport refrigeration is quite important. The cold chain is quite important. You have this beautiful logo here. So in order to have such trucks, in order to have such systems, you do need to test. And so the project developed this test chamber, which is pictured here on the publication, and it was actually finished in May 2017 when it was commissioned and handed over. And please, I do not know, Mr. Ackermann might enlighten us on this one, if these people whose names appear here are still operating it, or if it has fallen by the wayside, perhaps even. What happened is one of those companies, Transfrig here, who is actually doing transport refrigeration systems, was also involved, and they tested and they developed a system which was running on 290. And of course, with regards to safety, because it's a mobile equipment. So if something happens, if the truck turns over, doubles over in a curve, of course, you don't want anything with that 290 untoward to happen. So yes, so they tested this one. According to Mr. Ackermann, Transfrig was bought by somebody else, and they were not so much interested anymore in this one. But the project has reached a stage where a standard, you could call it a standard production model. So this system is actually available. The knowledge is available in South Africa and also can be recalled, of course, from ProClima. Now, earlier on my slide, I showed you virtual power plant microgrid. So I show you this slide only because I liked so much the slogan. What is a virtual power plant? It's all power, no plant. That means it's cheap. Now, what does it mean? Siemens here has another similar thing. This is the virtual power plant, and this is a microgrid, this whole thing. The microgrid has storage. The microgrid also has, this is actually a helipad, but I like to say it's hydrogen. It's hydrogen storage. It has, of course, a connection to the grid, and it has users. So this is a microgrid according to Siemens. The information is available from their website. Another German organization, Energy and Meteo, has it here a little bit described for your benefit. It's a decentralized system that uses the decentralized power and it distributes it between generation and between consumption, and makes sure there is a stable supply of electricity. Now, this slide is from a Canadian company that is offering the same thing, a virtual power plant. It's basically only a computer. Why do I show you this one? Because they quote, this company, Enbala, is quoting the US Energy Information Administration, and they have a very interesting statistics. You may know from the news, the United States, Mr. President, he digs coal, as he calls it, and he wants to encourage more coal-fired power plants. Yet nobody in the United States builds any more coal-fired power plants. Why is that, if the president is even pushing it? So the reason for that one is written in this very small text here. A coal-fired power plant, if you want to build a new one, costs anywhere between $3,000 and $6,500 per kilowatt hour, depending on what technology you use and where in the United States you build it. However, the United States is building a lot of natural gas plants, and they are very much cheaper. So even the most expensive ones are still much cheaper than the cheapest coal-fired power plants. Anywhere between, shall we say, $700 and $2,000 per kilowatt hour is the price tag for a natural gas-fired power plant. But if you go for this system, and the one from Siemens and the one from other companies, then you can put it up for just $80. 80 versus this number versus this range. And that is what the Californians are doing. That's what the Canadians are doing. That's what other states in the United States are doing. So that is probably where it goes. And South Africa can do it. These systems are readily available. Obviously, they don't cost that much. So Aldi Süd, in this case, is also interested in that kind of thing. So they have a virtual power plant. They installed a virtual power plant, a mini thing, a mini microgrid, a mini virtual power plant, which is only doing, where do I have it here on the slide, something like, or is it on the next one? No, on this one, they have 3 stores in which they actually have integrated, where they have also energy storage, and they add another 7 stores where they also have solar energy, and they manage this kind of system in order to learn about it. And interestingly, just to say, this one here, NBW, is the energy agency of the German state of Baden-Württemberg. So it's not just private, it's also the government is also interested and involved. And they use batteries. I am showing you later in the next slide that batteries is okay, but battery is not the only way to store energy. Better, you look at this kind of slide. Batteries have their role, yes, it's quite a big one. They can store about a megawatt or several megawatt. This is a logarithmic scale apparently, and they also store it for a certain time, not very long. So here you can see batteries have a limited storage time. Now, I said earlier, pumped storage, that is here, hydro pumped storage, like what can be done with the mines here or pumping up to a mountain, is in the mid-range. It can store a lot of energy, and it can store it for a certain time. Of course, you can store it there forever, but that's not the idea of having a battery. You don't want it forever. You want to use it. And then my favorite is this one, hydrogen. I'll come to that in a moment. You can split water into its components, hydrogen and oxygen, and when you bring it back together, then you will generate electricity in a fuel cell. I come to that. E-methane is interesting here. We are talking about Germany. I would like to just give you the example. The American foreign minister is blaming Germany that we are depending too much on Russian gas deliveries. Russia is sending a lot of gas. There's a new pipeline going to be built, and they say, oh, this is strategically terrible, and you should better buy gas from the United States. Okay, so it's business, is okay. The Germans cannot quite understand what he's talking about, because we have 1 terawatt, that is the equivalent of all the energy that Germany needs in about a year or so, in gas, in the form of gas in our gas net. Every household in Germany is connected to a gas grid. I know I'm talking to South Africans, you don't have that, but in Germany, this is a strategic reserve. We have a lot of gas that we can use. Even if Mr. Putin shuts down the gas supply, we can negotiate. I put this natural gas because natural gas can be fed into a fuel cell here. Also, you can put hydrogen, you can also put natural gas, which is methane, and you can produce electricity and cooling and also heat. Depending on what you need more, you produce electricity and then you have a byproduct, cooling and heating, or you use heating and then you have a byproduct, electricity and cooling, and so forth. That is this trigeneration kind of thing. The company Intelligence had just been picked up by Fuji, the Japanese group. It's a German company, Intelligence. What is a fuel cell? Now, some of you might sit here and say, what's the man talking about? How does a fuel cell look like? This is actually an experimental kit you might want to use in school, or you might want to buy it. It's cheap for your children so that they can understand. This is, of course, plexiglass, and inside here is a little membrane. The membrane is surrounded by water, and if you apply electricity to it, then the water will be split. On one side of the membrane, it will be H2, hydrogen, and on the other side, it will be O2, oxygen. So you can catch it, actually, if you like, and then you can bring the hydrogen and the oxygen together, and then you can harvest the electricity. It's renewable. This one here is renewable. You can put it on a little toy car. Horizon actually sells toy cars for children, where they can learn that this one is a process that can be operated by the sun. Now, that's a model. In the reality, fuel cells are stacks, you know. These ones here, thousands of them, are stacked together, scalable into any size. So here are some suppliers. This is a small one, relatively. It's from Austria, Fronius. Used to be my favorite, but now when I called them recently, they said all their engineers are now busy working on the hydrogen and fuel cell technology for filling stations, because cars are switching from e-cars now to fuel cell cars in the future. And why am I so certain? Because that happened, that was touted 15 years ago, and then 10 years ago again, and then 5 years ago again, it petered out. This time I believe it. Why? Because there was a car show in Shanghai quite recently, and obviously everybody is rolling out their electric cars, battery-operated electric cars. And then there was a speech from a Chinese official. His name is Wan Gang, and he is considered the father of Chinese electric cars. So he was the one instrumental in the technology rollout and in the policy rollout, and is credited with the electric cars that are currently on the road in China. And he made a speech and he said he had just given the job of now doing the same for fuel cell vehicles. So we can be reasonably sure that China is going that way, and China is putting one fuel cell, one hydrogen gas station after another in all the big cities, and the cities declare themselves, meanwhile, hydrogen economy cities. So they are heavily pushing in that direction. So this is a small one that fits into a house, actually. It's certified by TÜV. This is a big one. From a big company, Hydrogenics, one of the old companies that is producing fuel cells from Canada. It's container sized, as you can see, substantial business. And here again, a small one, because Fronius is now working more on the gas stations. So this one is for a house where you can actually store your hydrogen for winter. In Germany, we have cold winters and we need an energy storage for winter. It's today we use gas, and a few years back we used oil in big containers in the basement. So now you can store hydrogen, and it is a Berlin company operating out of Adlershof. And with whom do you do that? With a Norwegian company, NEL. And you might remember NEL from the newspaper. They recently had a fire. Bad, a fire. Whoa, hydrogen is definitely flammable, more so even than propane, and has more energy content in every liter or every kilogram of gas. So they are figuring out now, according to what I said earlier, they figure out what happened. What do we have to do in order not to let that accident happen again? So this is NEL, current latest news. They are working together with RTS Africa. Here is the source. If you are interested, you can look it up on the internet. And that is actually a cost-effective solution for relatively high volumes. But the equipment is just a box like that. It's not so big after all. Now, there's one problem in South Africa. If you want to generate hydrogen from water, you have no water. We're in Cape Town. Big problem, not a good idea. So what can one do? This slide is not going in that direction, but it is very helpful. Many, but in my example here, a Finnish company actually has figured out how to use seawater, or you can also use brackish water from inland sources if you have, in order to generate hydrogen. And they do that. It's not so far away, together with Namibia. Down in the Namib Desert, the University of Namibia has this station. This is actually Namibia. And this is the Finnish guy who helps put it together. So there is desalination going on. The water that you desalinate, you can use for anything, but also you can use it for hydrogen. Now you might wonder, why is this guy talking the whole evening to us about this one? I think it is essential. We are old guys, young guys here. There is another generation coming after us. And they want to have a world in which it is worth living and not a world overheating like what we are afraid of right now. So that is one of my driving factors to speak to you tonight. And obviously, as a country, South Africa, or country Germany, we have taken upon us certain obligation in the Paris Agreement, namely by the year 2100, which is exactly the generation coming now. The Earth should not, as much as possible, go beyond 1.5 or at best, at most, 2 degrees centigrade. Now, 1 degree is already in our atmosphere. 1 degree is already gone. We cannot do anything about it anymore. 1.5 is very likely going to come and more. So the people who deal with this, they figure after 2050, we actually have to take CO2 out of the atmosphere. And thankfully, many people, many institutions are working on ways of how to do that. There are some successes. I leave that for later. I want to show you how real the problem is. This is a picture. It's from 2017. It looks every year like that. You can look it up on the website here. A very interesting website. Every day, with 1 day delay, they show you what is the situation on the North Pole in this case. You can also look at the South Pole. Here, this picture very clearly shows, in the North Pole, in the minimum, when the most ice has melted in the year in September, there are large areas which are actually not really covered by ice. It's just icebergs. There's a lot of open water in between, and there's a little bit of solid ice area here just in northern Canada. So that's bad. And this dotted line here, this dotted line is the absolute worst year that we had in 2012. And just now, when I looked up this website recently, we are again on a year like 2012. So it's maybe interesting for the one or the other of us to follow from now into September to see what the situation is like going to be this year. What does that mean? Going back here, we have a huge glacier ice mass here on Greenland. And as you are very well aware, there is a huge ice shield on Antarctica. And both these ice shields are in terrible shape. And more scientists are realizing there is something going on that is escalating. It's getting faster and faster and faster. The ice is melting much faster than ever anybody had thought possible. And the result of it is sea level rise. So I encourage you to look at the website. This one here is the website. I was in Durban, I was in Port Elizabeth, I'm now in Cape Town. So I just set the thing at 1 meter because everybody is relatively sure 1 meter is not much. So 1 meter is going to come, and most likely much more before the end of the century. So in Durban, You see here the port facilities, so they are endangered. It doesn't mean it is all going to be flooded, but it requires a lot of effort to stop the water from damaging your port facilities. Port Elizabeth, and again, I must say, maybe this picture would have been better with a satellite image. You can switch that here, satellite. If you click here, you can see the ships here, so you can see a little bit more clearly where the water is rising. And this is Cape Town. You know, your wonderful port area there, much of it is actually endangered. And of course, also the coastlines up and down, this is just the ports. Why do I point out the ports? Because you want to export from South Africa, for example, apples, for example, wine. You want to import all sorts of things into South Africa. Now, if you say, oh, we South Africans are relatively lucky because that damage is not so much, you can handle it. You throw a lot of money at it and then you can handle it. But where do you bring your produce? This is Friesland. Friesland, there's much of your produce is going to Friesland. This is Netherlands, this is the northern German coast, this is going to Denmark here. Everything will be submerged. My hometown is here. It'll be 50 kilometers before I reach shore when the water rises by only 1 meter. So no Rotterdam, no Hamburg, no Bremen. All of these things will be destroyed, and obviously also on the British side and obviously also on the American side. Don't think this is limited to our little sliver of the world. So that is a serious thing, and this one is not so easy to repair. So that will be a relatively permanent damage. I'm talking to refrigeration people. What can we do? We are in a fantastic position as a group. 20 gigatons, I told you earlier, 20 gigatons are sitting in the existing air conditioners only, and there are many other applications than just air conditioning. So we could help, by using natural refrigerants, in particular 290, which is technically feasible, economically attractive, and is absolutely responsible to use that kind of technology. Now, with that, we could do away with this extreme global warming potential that we have from HFCs, and we can actually even save a lot of energy, save a lot of money in operating that equipment. Yes, the future is yours. The future needs refrigeration, lots of it. It's getting hotter, so refrigeration and air conditioning is absolutely necessary in order to maintain the productivity of the workforce. If it is very hot and humid, people do not work as efficiently and effectively as in properly cooled or in some parts of the world warmed rooms. And yes, natural refrigerants are actually good business. If you want to do more and more business, consider natural refrigerants R290 because that is good equipment. And yes, you should know from latest after this lecture tonight that it is safe to use these refrigerants. There is no reason to be scared of it. There is reason to be careful, like you are careful in your car. You don't drive over a robot just blindly. Not a good idea, right? So that is the safety measures you also can apply to natural refrigerants. And in most cases, hydrofluorocarbons are not needed anymore. There will be always a little part of the market that requires these refrigerants, and that is okay. The Earth can take that. And then again, my last part of my lecture, if you want to do something extra, consider where you get the electricity from. You can integrate technologies properly with renewable energy, with microgrid and energy management and so forth. And the last word, it is urgent. We cannot wait, and we cannot say, oh, let the other ones do it first. All of us have to do what they want to do, what they can do, and we have to do it all at once. And thank you for this long lecture and listening. I wish you a good evening.